Hello students, so today in this lecture we will be talking about few nanocomposites. The first one we will start with gallium nitride. This is cubic. When this is deposited on nano patterned 3C-SiC, which is further deposited on silicon 001. Now what we are mainly focusing on is this gallium nitride here. It actually is a group 3 nitride. Other group 3 nitrides apart from gallium nitride can be aluminum nitride, and indium nitride. They have the following properties. They have got white band gap. They can be made into used in optoelectronic and electronic devices. And they can be also used in laser diodes, and transistors. Now the main challenge in these is its fabrication, where we have to fabricate a dislocation free epitaxial layer of gallium nitride. Epi layer of gallium nitride. So that is why a lattice matched substrate is will give you the best performance. So a lattice match is required or will give you the best performance of these devices. Whereas lattice mismatch will cause misfit dislocations at the interface. this misfit dislocation, at the interface will cause scattering of charge carriers, also will cause limited carrier mobility, and also cause non-radiative recombination. Now the question is, the choice of the suitable substrate is limited. The choice of a suitable substrate is limited. Therefore, we have to opt for other techniques. So, an additional techniques are required. One of the methods which actually causes a reduction in growth area. So, one method which can be employed, which actually causes reduction of growth area, it's called nano heteroepitaxy. Nano heteroepitaxy. NHE. Now this NHE is basically a selective growth on nanopattern substrate. So we're talking about selective growth on nanopattern substrate. What we actually do in energy is there is a partitioning of strain in the epitaxial layer. So there is partition strain in epi layer. And we do it by a 3D distribution of mismatched strain. 3D distribution of mismatched strain. and with the help of energy we actually can possibly grow dislocation free affiliates. So a possible dislocation free affiliate can be made with the help of energy, and this actually takes place, this dislocation free polarity takes place on non-lattice mismatched nanopattern substrate, on non-lattice mismatched nanopatterned substrate. Now this gallium nitride, as we have started with this gallium nitride, it actually causes, for the case of 3C-SiC, this actually provides very less lattice mismatch. It is only 3.5% of lattice mismatch can take place. Lattice misfit is possible with the low gallium nitride, and this has got very low dislocation density also, that is around 10 to the power 9 to 10 to the power 10 per centimeter square. And due to this particular nanocomposite can be used in field effect transistors, VT, and also in IR detectors. And as we have a reduced dislocation density, this is the reason why the devices made up of these materials, they have a higher performance. Now this nano patterning that we have that we are talking about, this 3C-SiC on silicon 001 substrate, this nano patterning this can take place either by two methods. One is called electron beam lithography, and the second one is called self-organized collateral masked. There are, coming to the defects, there are basically three basic defects associated with gallium nitride and 3C-SiC. three basic defects in gallium nitride 3C-SiC Si001. Three defects are misfit dislocations, dislocation in substrates, and stacking faults. Now this misfit dislocation this actually is due to the relaxation of the string behavior. The second one, the dislocation in substrates, they actually extend into the plate. And lastly, stacking faults. They are on this 111 plane. Now, if the growth area is small, then this misfit strain is partitioned. Nice. Partition, like an example, say this is your epitaxial layer and this is your substrate, this is your WP layer. Now instead of this, we somehow use a nano pattern substrate, and this is your WP layer. So by reducing the area, we actually are reducing the misfit dislocation, or by partitioning the area we are reducing the growth area is being reduced by partitioning the area. Now what happens here is that in this case where this is a nano pattern substrate and this is your epi layer. Now both the substrate and the film are not subjected to lateral confinements. So both film and substrates reduction in area due to patterning, there is no lateral confinement. Due to this, so write it again, no lateral confinement this what is happening, this out of 3.5, 3.2% of mismatch is accommodated. Mismatch it is accommodated. And also there is no defect generation. No new defect generation is also not taking place. Now, nanosphere lithography is a technique Nanosphere Lithography. So this nanosphere lithography, in short, you can also call it as NSL. This is a technique where 3C-SiC this films, sorry, 3C-SiC films are grown by chemical vapor deposition on silicon 001 substrates. Now, silicon carbide is basically hydrophobic. That is, it repels water. Therefore, the silicon 001 is coated first with an silica SiO2 by PECVD, and which is followed by a cleaning process. You clean the whole system by the following composition: H2O and H3 2O2, and their entry is to 1:1 composition. So clean the substrate, back to the surface, and then the surface is covered with a mask, which is basically 600 nanometer polystyrene spheres. Now, controlled drying of the system takes place. And you get we actually do this controlled drying by an aqueous solution of colloidal polystyrene. Aqueous solution of, so this is what it as PS, of aqueous polystyrene. What happens is that these are basically in spherical. There are basically polystyrene spheres. So this controlled drying, they shrink the spheres in oxygen plasma. So there is an oxygen plasma which actually causes shrinking of the polystyrene spheres. So oxygen plasma, so PS spheres, they shrink. And on top of the colloidal mask, 60 nanometers of nickel, nanometers of nitrogen nickel is thermally incorporated. So a nickel of 60 nanometers is again incorporated by thermal evaporation on the colloidal mask. The nickel mask is then so we have a nickel mask on 3C-SiC, which is deposited on silicon 001, and then the process of reactive etching takes place. It's called RIE, reactive etching, and it takes place around 10% O2 and 1% SF6. After the nickel metal, after this reactive etching is taking place, the nickel metal is removed. So metal removal by ferric chloride, FaCl3, and DI water in 1:3%. So we actually get a patterned substrate as we already mentioned. So this is a patterned substrate is formed uh, with the hole diameter of 400 nanometers and depth about 300 nanometers. Now, apart from this technique, electron lithography technique can also be used, electron beam lithography. So after the nickel metal has been deposited on 3C-SiC Si001, then plasma etching can take place using an argon or oxygen atmosphere. Electrons are generated and they etch the substrate, and etch rate is around 100 nanometers per minute, and we get pattern substrate like this. This is electron beam lithography technique for forming a pattern substrate.